Hello, in this chapter we are going to start the effect of tribology on surface of nanomaterials. So, first as an introduction we can say, or maybe last subsequent chapter we have gone through that different types of parameters like frictions, wear, lubrications. So, in a single word we can say that all together is coming or maybe giving a definitions is called the tribology. So, tribology is a science of frictions, wear and lubrications. So, all together is known as the tribology. It is employed in monitoring the conditions of a machines or equipment through the analysis of the characteristics of the lubricants being used in it. So, it is a process, it is a combinations of process by which we can see that when the machine is coming and then it is installing, then after that when it is starting. So, from starting to the ending, the whole life, is there any problem or fault inside the machine or not, is there any wear or maybe tear or maybe the noise problem inside the machines or not, whether the proper lubrications is there or not, or maybe is there any fault. So, the whole thing is known as the tribology. Nanotribology is a dynamic interactions through relative motions of two contacting solids, and it automatically involve how the response of material with respect to other material. So, in our first slide we have discussed about the tribology for the macro level. Now, we are discussing the tribology for the nano level. So, nano level means nowadays we are talking about the nano. Each and every time we can heard that term nano. Nano is nothing but the materials which is having the 10 to the power minus 9 meter in size. So, when we are dealing these small particles, when these small particles also coming into the contact, there is having some kind of tribology or maybe some kind of frictions or maybe some kind of wear. So, the tribology which is dealing that part is basically called the nano tribology. Where we require study of tribology for nanomaterials, it is an ideal way to study friction and wear process of the nanostructures. Study of interfacial phenomena at nano levels has significant applications like magnetic storage systems, NEMS or MEMS. Here I have given only 3, but there are n number of examples are there. Nowadays we are using mobiles, nowadays we are using some kind of iPads, laptops, where the size is getting smaller and smaller. So, whole the storage systems and the operating systems is going into in higher magnitude, right. Previously we are using 10 megabyte storage system, nowadays we are using 1 terabyte storage systems, and it is going more and more, but relative to its dimensions and weight it is going into the decreasing manner. So, the materials is giving more properties, but its dimensions and weight or maybe the size is getting into the smaller sections. So, when we are compacting these all materials, that means there is a direct contact in between the materials itself, which generates the friction. So, when you are talking about the MEMS or maybe any kind of semiconductors or maybe any kind of electronics device, there are n number of chips, n number of diodes, n number of materials are using, which is size is very small, maybe some materials which we can't see by our naked eyes also, but still they are coming into the contact and some wear or maybe friction is going on. So, what is the difference between macro tribology and nano tribology? In the macro tribology, it is the bulk mass, the size and weight of that particular equipment or maybe the machines are bigger. Heavy load, generally we are applying heavy load onto those machines or maybe they are generating heavy power or maybe heavy energy or maybe heavy load. More wear, maybe there are n number of materials is touching together. So, if we accumulate all the wear, so the volume of the wear may be more at that particular case, and it can see into the macroscopic level or maybe sometimes we can see it by our naked eyes also. But when we are talking about the nano tribology, it is very confined one. It needs some precise equipment to observe the tribology or maybe the wear or maybe the aberrations. It is sometimes it is very difficult to measure those functions, and also maybe the wear can be robust or maybe the wear can be less also. we can't use maximum load as like the macroscopic level, because that material does size and shape of that particular material is less. So, sometimes maybe they are the sophisticated one, so they can't bear that high load. So, sometimes we are giving the low load also. So, there are several number of differences in between the macroscopic level and the microscopic level. Fundamental facts of our tribological studies. So, from this slide we will see that what is the why we are doing the tribology, what we are getting from the tribology itself, or maybe that rather what we are gaining from studying the tribology. So, first is called the all mechanical, physical, chemical and geometrical aspects of the surface in contact of the surrounding atmosphere affect the surface interactions and hence the tribological characteristics of the systems. So, from morning to night we can see each and every time maximum materials is coming into the contact, rather when we are walking onto that surface also our feet or maybe our shoes is touching with the surface. So, without contact nothing is possible. So, that time it is generating certain kind of frictions, it is generating certain kind of heats by which material is getting degraded. So, the tribological parameter always it is coming into the picture. Friction and wear are important parameters and they are unique characteristics of the tribological system in which they are measured. Also, tribological properties are not materials but system parameters, as I told already that it is called the system response, it is not the any kind of phenomenon. We are doing some operations, that is why that machines or equipment is giving that response to us. Tribo testing has to be an integral part of both the process of developing tribomaterials and in selection of materials for application involving friction and wear. Nowadays lots of scientists, lots of researchers are working on this particular topic, how to reduce the friction, how to reduce the wear and how to give the maximum properties or maybe the maximizing the life of any equipment or maybe machines. Now, we will discuss that why nanoparticle research is gaining interest. So, till now we are discussing about the macro level, but why? As I already said that nowadays we are trying to do every research on into the nano level, because there are plenty of variety of things is available. Not only that, we can synthesize those materials, that materials is having very fantastic properties than the virgin materials or maybe that composite materials. Not only that, that material chemical properties, physical properties are more than 100 times, 200 times, 300 times better than the normal material. So, that is why nowadays people are doing research on the nanoparticles. So, recently nanoparticles have attracted increasing interest and have been used in a lot of energy related fields owing to their unusual electric, mechanical, piezoelectric properties. So, as I said already, nanoparticles is giving some extraordinary properties regarding in terms of physical properties, in terms of mechanical properties, in terms of chemical properties, in terms of electrical properties, and also simultaneously its shape and size is also small and also it is less expensive and you can easily carry from one place to another. The nanoparticle could be used as nanolubricant additives in automotive engine to improve the tribological performance, oil properties. Nowadays we are using certain kind of nanoparticles, some kind of coated nanoparticles which we are putting as a emulsions or maybe mixing directly to the lubricating oil, so that when it is coming into the contact in between that surface it can absorb the more energy than the oil itself, or maybe it can exert the energy at the dump site, so that that material can be used for a several times, it will not break, it will not lose its properties. The addition of nanomaterials to lubricating oils can effectively improve the tribological properties through the formation of a protective film on surfaces and creating a rolling effect between the friction surface. And not only that, these nanoparticles are sticking with the surface of two mating parts, so that if there is some pressures or maybe frictions also, they are not leaving those surfaces. That is why always there is a lubrication film is formed, or maybe the surface is always lubricated. Next is called the why surface engineering of the nanomaterials required. So, from this particular slide we can understand that when we are doing the surface engineering, then why it needs. The thing is that now we have made some materials, now we are using those materials, but that materials is getting some problems in terms of wear, abrasions. So, now we have to rectify these problems, but if we replace these materials, it will be very expensive. So, what we will do, either we will do some kind of coatings or maybe some kind of modifications in terms of chemical or physical, so that its properties get increased. That particular is coming under the umbrella of surface engineering. So, surface engineering is a surface modification techniques employed to improve the function and serviceability of materials. It improves lots of applications, lots of properties like corrosion resistance, oxidation resistance, wear and friction resistance, mechanical performance, electrical and electronic properties, thermal insulations, aesthetic appearance. Here I have mentioned a few, but there are n number of applications, n number of properties which can be modified by using the nanomaterials. How surface engineering can be applied to nanomaterials? So, first initially that nanoparticles can change the surface chemistry, it can react with the base metals or maybe it can make a coatings onto the base materials, so that that surface will not directly come into the contact with the environment or maybe it will be lubricated. Second is called the changing the surface metallurgy. So, we are adding certain kind of nanofillers into the base metals and doing the mixing or maybe making some kind of alloys or composites which is giving a tremendous property than the virgin material. Next, adding a surface layer or coating. So, on the top of the surface we are giving certain kind of coatings, so that it can made a film like structure. So, or maybe sometimes that nanoparticle is making a reactions with the base metal, so that it can form a self coating to its outer surface, so that the material will not be eroded or maybe not be corroded. Next, changing the surface chemistry. How we can do? We can do by the carbonizing method, which will increase the wear resistance. Carbonizing is nothing but in the carbon environment, either we can heat that material or maybe we can add the carbon content to that particular material, so that the material will be resistant in some particular environment. Next is called the nitriding. Nitriding means the same thing. Now, instead of carbon environment, we are putting those materials into some ammonia environment or maybe some nitrogen environment, where that material can absorb the nitrogen in it, or maybe nitrogen can create certain kind of film onto its surface, so that the material will be corrosionless. Next, called the diffusion, improves corrosion resistance. We can heat that material, so that material can diffuse and it can generate some kind of verging properties or maybe some kind of verging surface, so that it will be non-reactive to the environmental surface. Next, called the ion implantations. So, here we are having some kind of precursors by which we are giving certain kind of energy to that particular precursors in terms of maybe heat, in terms of pressure, in terms of load, so that it can release some kind of ion. So, that ion directly it is coming and it is reacting with your base metals or maybe coated onto your base metals, or maybe it is going inside your base metals and doing the implantation, so that your base material properties is going to be changed. And the last one is called the laser alloying, improves the wear resistance. From that name itself you can understand that we are using certain kind of laser. You know the what is the meaning of laser? It is the called the light amplification of stimulating emissions of radiations. So, just we are creating the laser, then we are putting that laser onto the metal surface. Due to that laser, either the material is getting heated up or maybe the laser is penetrating inside the material, so that it can change its properties of that particular base materials, or maybe some kind of laser pinning, which will come into the next slide or maybe the subsequent slide. So, due to that repeatedly we can depress the surface of that particular base materials, so that it can make a film or maybe the solid film, so that it can't react with the environment itself. Changing the surface metallurgy. So, by doing the surface hardening, that means we are applying certain kind of temperature or rather in our metallurgical term we can say it as a heat treatment process. So, we are heating that material into certain temperature more than its crystallization temperature, but below its melting temperature. So, that the material properties can be changed, new crystal structure can be formed. So, by which the material will behave in a good manner, or maybe its rather its physical properties or mechanical properties will be improved. Second is called the laser melting, already I have discussed, by which we can increase the wear resistance and the formation of fine dispersions of the precipitates. And last one is called the shot pinning. Shot pinning is nothing but the, I can give you one example. Suppose you are having one surface and top of that surface you are having some balls, either these balls is made by the ceramics or maybe some kind of metals. So, if you are having several balls and if you allow those balls to fall, free fall from the certain height, so it will gain certain kind of kinetic energy, that kinetic energy will come directly and that ball will hit that surface. Due to that your surface will automatically depressed, or maybe if there is any cracks and pores is there, it will be compressed. So, a hard layer will be formed on top of the surface. This is known as the shot pinning operations. So, by applying the laser or maybe applying the some normal ceramic ball, we can do the compression of that particular surface, by which we can modify the surface properties or maybe the surface of that particular material. Next, adding surface layer or coating. So, there are several types of coatings which we can apply to that particular material. So, first one is called the deep coating, used to improve corrosions and oxidation resistance via sacrificial protections. So, we are putting that material into some chemicals by which the whole material can be covered by some other material which is non-reactive to the environment itself. Electroplating, so we are using some anode and cathode, we can create certain kind of potential difference, so that one material will be eroded and that will make a coating onto the another material, right. So, whatever the material we are using for coating, that material should be less corrosive or maybe less oxidative to the environment itself. Next, called the thermal spraying, used in thermal barrier protections, electrically conductive coatings and dimensional restorations. Mechanical plating improves corrosions and wear resistance. CVD is called the chemical vapor deposition process. So, in that particular case we are doing certain kind of reactions. So, some kind of vapor is forming, then that vapor we are allowing to substitute or maybe the deposit onto your surface, so that your material surface will be getting some kind of cover. And last one is called the PVD, which is known as the physical vapor deposition process, by which we can improve the electrical and optical properties. So, last two methods we can create certain kind of vapor which can directly come and make a layer onto your surface. Now, we will discuss about the some important techniques for surface analysis. So, how we are going to measure that is there is any wear or maybe there is any abrasions, or maybe when we are doing some kind of coatings, how we can measure all those. So, first one is called the friction and wear tribo tester. So, it will give you some kind of noisy signals by which you can understand that whether your coating is proper or maybe it is worn out, so that you can go for the second times. Next, called the scanning electron microscopy. So, by seeing it into the microscopic levels, you can zoom the figure, you can see that whether which there is any cracks or maybe any kind of pores are there or not, which we can't see from our naked eyes. Next is called the transmission electron microscopy. Next is called the 4-ball tribo tester, radial journal bearing wear test rig, atomic force microscopy. EDS is called the energy dispersive spectroscopy, XPS is X-ray photoelectron spectroscopy, pin on disc tribometer. So, these all will give you the different properties about the materials. Not only that, it will not give you only the surface properties, also it will give you the atomic level properties of that particular material too. Now, in the next slide we will discuss that what makes nanomaterials innovative for the tribological advancement. So, why we are using the nanomaterials, what advantage actually we are going to get by doing this surface engineering. So, now nanoparticles can act as a nano bearings on rubbing surface. Deposition of nanomaterials on rubbing surface mostly improves tribological properties, already I have discussed, because in the macroscopic level if you see that if I am having a bigger particle, it is very difficult to stick onto the surface, but if I am having a very fine powder, so it is easier to them to easily stick with that surface itself. Next, nano lubricants are relatively insensitive to temperature and the tribochemical reactions are limited as compared with the traditional additives. These are less expensive and it can be easily fabricated in the lab itself, so that it is having some wide applications. Addition of nanoparticles to lubricant is very effective in reducing the wear and frictions. Friction reduction and anti-wear behaviors are dependent on the characteristics of nanoparticles such as size, shape, concentration. So, depending our requirement, we can increase or decrease the size of that particular nanoparticles, we can do certain kind of coatings of that particular nanoparticles. So, by which we can use that lubricants for several applications. Thank you.